Good morning, my dear students. Today I am going to teach you the substitution reaction. It's an important part of organic chemistry. What is substitution reaction? First, I would like to show you an example. This is methane. When methane reacts with chlorine, one hydrogen atom of methane is replaced by chlorine atom to produce methyl chloride, and one hydrogen atom of methane combines with one atom of chlorine molecule to produce hydrochloric acid. So what will be the definition of substitution reaction? The reaction in which an atom or group of atoms in a molecule is replaced by different atom or group of atoms are called substitution reactions. There are three types of substitution reactions. One is electrophilic substitution reaction, nucleophilic substitution reaction, free radical substitution reaction. Today I will discuss about the electrophilic substitution reaction. Friedel-Crafts reaction is one of the example of electrophilic substitution reaction. Friedel-Crafts reaction. Friedel-Crafts reaction. There are two types of Friedel-Crafts reaction. One is Friedel-Crafts alkylation reaction and another is Friedel-Crafts acylation reaction. Friedel-Crafts alkylation reaction, Friedel-Crafts alkylation, Friedel-Crafts alkylation reaction. In the presence of dry aluminum chloride, dry aluminum chloride means anhydrous aluminum chloride, absence of water. Benzene reacts with alkyl halide to produce alkyl benzene. To produce alkyl benzene and hydrogen halide. This reaction is known as Friedel-Crafts alkylation reaction. Actually, in the Friedel-Crafts alkylation reaction, alkyl group is bonded with, alkyl group is added with benzene ring. That is why this is known as alkylation reaction. My dear students, all of you know that each of the hexagonal corner of a benzene ring contains a hydrogen atom. This hydrogen atom is replaced by alkyl group. Here I have used methyl group as an example of alkyl group, and this hydrogen atom combines with chlorine to produce hydrogen chloride, and hydrogen is replaced by methyl group to produce toluene. This compound is known as toluene, or this is also known as methyl benzene. Toluene. So as an example, I can say in the presence of dry aluminum chloride, benzene reacts with methyl chloride to produce toluene. This is an example of Friedel-Crafts alkylation reaction. And Friedel-Crafts, the another one is Friedel-Crafts acylation reaction. Friedel-Crafts acylation reaction. Friedel-Crafts acylation reaction. In this case, acyl halide is used instead of alkyl halide. If I use here an example, benzene, this is acyl halide. I mean, if I write the specific name of this compound, it will be acetyl chloride. In the presence of dry aluminum chloride, benzene reacts with acetyl chloride to produce acetophenone, to produce acetophenone plus hydrochloric acid. Here, if I say the statement of Friedel-Crafts acylation, clearly it will be as like dry, in the presence of dry aluminum chloride, benzene reacts with acyl halide to produce acyl benzene. As an example, in the presence of dry aluminum chloride, benzene reacts with acetyl chloride to produce acetophenone. Now I will teach you the mechanism of both Friedel-Crafts alkylation and acylation reactions. Mechanism of Friedel-Crafts alkylation reaction. First, to write the reaction, Friedel-Crafts alkylation reaction, in the presence of dry aluminum chloride, benzene reacts with methyl chloride to produce toluene. And mechanism actually at the first step, methyl chloride reacts with aluminum chloride, dry or anhydrous aluminum chloride. My dear students, all of you know that the charge of chlorine is negative. So this negative chlorine combines with aluminum chloride to produce aluminum tetrachloride ion. Aluminum tetrachloride ion. Here actually there are 3 chlorine atoms. After addition of another chloride with aluminum chloride, the total number of chlorine atoms becomes Cl4. 4, and the resulting ion is aluminum tetrachloride. And after reducing chloride ion, the remaining part is actually positive ion. This is known as methylenium ion. And this positive methylenium ion is actually electrophile. All of you know that electrophile or electrophilic reagent. But students, all of you know that the chemical species which attack to the electron density or negative center is known as electrophile or electrophilic reagent. At the second stage, electrophile attacks to the benzene ring. All of you know that benzene ring contains pi electron density. This circular actually indicates the circle sign indicates actually the delocalized pi electrons. This electrophile, methylenium ion, attacks to the benzene ring and benzene donates the pi electrons. to form an unstable carbocation. This is also known as sigma complex. Then at the third step, this unstable carbocation combines with aluminum tetrachloride ion. In this case, this proton releases electrons and proton combines with 1 chloride ion of aluminum tetrachloride to produce hydrochloric acid, and after reducing 1 chloride ion, the remaining part is aluminum chloride, and after donating the bond pair electrons of hydrogen of proton, toluene is produced here. That's all about the mechanism of Friedel-Crafts reaction. Now come to the another mechanism of Friedel-Crafts acylation reaction. All of you know that in the presence of dry aluminum chloride, benzene reacts with acetyl chloride to produce acetophenone plus hydrochloric acid. Here the first step, acetyl chloride reacts with dry aluminum chloride. Here also the chlorine atom or the chloride combines with aluminum chloride. This chloride combines with aluminum chloride to produce aluminum tetrachloride ion. And the remaining part of acetyl chloride becomes a positive ion which acts actually as electrophile. This electrophile attacks to the benzene ring. Electrophile attacks to the benzene ring to form an unstable carbocation, which is also known as sigma complex. Then this unstable carbocation reacts with aluminum tetrachloride ion. In this case, the proton returns back the bond pair electron to the benzene ring to produce acetophenone. And hydrogen combines with one excess chloride ion to produce hydrochloric acid, and the remaining part of aluminum tetrachloride is aluminum chloride. That's all about, my dear students. That's all about the mechanism of Friedel-Crafts acylation reaction. In my next lecture, I will discuss about the another examples of electrophilic substitution reaction. No more today, and goodbye.